And we've started. Okay. We're done. So, sorry. It's like being at home. I get listened to last. Even the dog doesn't listen to me. Other than, I gotta go out. Take the dog out. All right. Housekeeping stuff. Vis-a-vis with the exams, I have to wait. I still have a couple more people to take them. If you're here and you were unable to take the exam for whatever reason, please see me after class so we can make arrangements to get that done. I do have a person who's taking it on Tuesday after class. So as soon as I get all the arrangements in, I should be able to get at least the grades of the people who took the scale grades of the people who took it to you within the next day or so, I would think. That's the first little good nugget. The second one is the practical this afternoon. I don't know who's in the lab. Basically, it kind of works like this. I'll have as soon as I get in there, I have to put the stuff out and put it on the tables in the pattern that I use. It's very simplistic. It's going to have like probably 20 stations, labeling exercise. You move from station to station, and basically you're identifying the structures I'm pointing to. It's the superior vena cava, it's the femoral artery, whatever. Okay, that kind of stuff. And you see it labeled, and I'll have it all out there. There'll be a word bank. There'll be whatever, an answer sheet. There'll be that reference sheet that you're permitted to have. Don't start. Reference sheet that you're permitted to have. Everybody got that? Good. Okay. Yes, ma'am.
Can you say what's on it, the practical, just one more time so I don't listen?
Sure. Basically, it's peripheral nervous system, heart, and blood vessels.
Okay.
And so if you go back and look at that, and that it was the last lab that we did, just scroll to the end of that on that YouTube link. And at the very end of that link, the last, 10 minutes, you'll see all the slides that I'm likely to use.
Okay.
So it's going to be eye and ear. I think, just offhand, maybe there's a taste bud. And sometimes I'll combine a couple. It'll be 3 answers at each station of roughly 20 stations. And I do take partial credit. That kind of, and in the heart, you're going to see the same picture twice. You should know what picture that is. It's got all the goodies on the inside. Right?
Yep.
All good?
Yeah.
Very well. And now let us begin. We're going to go back to the immune system where we left. I'm happy the week's over. Back to normalcy. Football tonight, soccer tomorrow. Lots of soccer and football over the weekend. I'll be happy. It's good. Moving on. If you haven't figured out, I'm a sportsaholic. BLTN, better late than never.
There's traffic
Sure.
everywhere.
Sure, I heard that before. Where are you coming from?
Hopewell.
Oh, I don't go that way at all.
Well, I live there, and they don't tell anybody when they decide they want to do road work.
Oh, I hate
And
that.
I sat in the same spot for 15 minutes.
And they're like, you got the.
Yeah, and they let one way go and not the other.
Yeah, I got you. Yeah, we drove through there. You got Dr. Buxton for physics? Okay, yeah, he's over in that neighborhood. I don't know where he lives. I haven't passed the same deal. I know, because we drove through there. We used to go. I kind of ended up going. My wife and I would occasionally go kayaking at whatever that Raccoon State Park. That's pretty cool.
Yeah.
If you like kayaking, you're ever in Florida, there's a great place to go. It's in Apopka, called King's Landing for you Game of Thrones. It was named King's Landing before Game of Thrones got to be so popular. It's great. We were just there in May again for like the 4th time. We had such a good time. Just don't go on a weekend. It's too crowded. There's even a place next to it that's part of the same stream system that basically for a $3 fee to park, it's another state park, you can go tubing all day on that same thing. And there's a place right on the way there to rent big tubes, and you can just float around all day and have a good time. It's great. So it's a relatively, the kayaking's a little more expensive. But there's a lot to see. There's a lot of wildlife and stuff. It's a blast. And they don't care if you're, not that you would ever do this, if you take coolers with you and just sort of like hang out on the bank where there's a clear area and have relaxing beverages or other distractions. The first day we were there, they just, there was a lot of people having distractions. They canoed out there because it wasn't very crowded, and they're out there with a bunch of beers and other, a certain aroma in the air that was characteristic of things that when I was in college. Not that I would know anything about. Having matriculated in college this summer immediately after an event called Woodstock, which you may or may not have heard of. Just saying. I know I'm old, but we did that stuff. We were just as crazy. Moving on. So much for my sketchy history. So I don't know where we left off exactly because I didn't bother to check. But these are really the important part. Really the critical part of understanding how your immune system works are these two areas. Whenever I would hate to give you a percentage, surely more than half of the time, when you and I respond to an infection, bacterial, viral, fungal, most of the time it's antibody based. The COVID immunization is all about making specific antibodies. So this is how we do it naturally, and even touches a little bit on how you might choose to do it artificially. Okay, so that's the launch point for this. And so it's about these are antigens that are specifically not invading and altering cells. Could they damage cells by what they do? Certainly. But the distinction is whether it is whether the cell itself has been altered. So think cancer cells, transplanted cells, transfused cells, cells that have been tuberculosis, where the bacteria lives inside of the cell, are distinctive. So when we see that, the target antigens, okay, and this is what happened. Cells within those immunological structures, like a lymph node, will encounter a projecting antigen, a protein marker with sugars on the outside with which it is unfamiliar, and it will latch onto it, and that will, or they want to call it cross-linked, okay, and it will trigger what's called receptor-mediated endocytosis. That means it swallows that complex, and eventually it leads to making B cells specifically to make antibodies to go throughout your system to target any of these markers. So once the response is generated, it isn't confined to a particular area, like you put a topical antibiotic on something, on a problem with your skin. It's systemic in nature, and it's widespread, and it's very busy. Most of these, what they call clone cells, B cells, change into little factories to make antibodies known as plasma cells. And so they are the principal effector cell. A small percentage of these activated B cells may become memory cells, and they are important for immunological memory, and that is the basis of why we do immunizations or vaccinations. And effectively they're interchangeable terms. So, if someone wanted to get semantically, there's subtle differences that are there. So what happens, they make antibodies at a remarkable rate. So they become protein factories, because antibodies are effectively proteins. And they make them in such a way that we make thousands of molecules per second over a relatively short lifespan, and then they die. And those antibodies effectively go everywhere. And what they do, and you'll see the ways that they target for destruction. Basically, they'll slow them down, they'll identify them, they'll neutralize them, they'll form big clumps of them, and that allows your white blood cells, the other white blood cells, to come along and basically gobble them up and destroy them. So it's effectively a tagging immobilization mechanism. Okay, bad guy, get rid of him. And then somebody comes along, so more or less takes out the garbage. So here's the primary response. This is the first time. And when we get a secondary response, that's after you've had, say, like most of you had MMR, would be a perfect example of that, measles, mumps, and rubella. So the primary response, so here you can see the B cells will have these protruding markers, and interestingly enough, this is just what antibodies look like. that sort of Y-shaped, that double-stemmed apparatus. And here you have the foreign, whatever it is. Okay. Once it identifies that, effectively, it leads to activation and cloning. And so the cell goes from something like this, and it develops a huge amount of, as you can see there, that's endoplasmic reticulum specifically. It's rough endoplasmic reticulum because that's where we make proteins for export. Okay. And then again, a small percentage become memory cells. And the beauty of the memory cell, all of this information is pre-encoded into the memory cell's, if you will, hard drive. It's like you loaded an app and that app is in there, and all you have to do is push a button, and all of a sudden it cranks out massive amounts of antibodies. That's not what happens initially. The primary response is effective but slow. The secondary response is effective but very, very rapidly onsets. So these are the memory cells, what we call immunological memory, and their response is immediate to future exposure. So that's the idea. If you want to take it to a flu shot that's going around, now we're sort of pre-encoding that mechanism. And let's say the flu bug hits here and you had a flu shot and the flu shot worked. That's a whole other discussion. Okay. Theoretically, the most you might notice, I have a scratchy throat today and a little bit of a headache. And next thing you know, I feel great the next day. That meant that your body ramped up and made antibodies before that thing got in you and started to do some business. And that's sort of the distinction. And what this sort of leads on to, and it's a more, it's a longer discussion. It's a theoretical and a philosophical discussion about the pros and cons of antibodies. And I touch on it a little bit more in micro because we discuss preservatives, and a lot of times it's not what's in the immunization, it's how they preserve the immunization. And for a long time they used substances so the viruses don't, preservatives keep it away from being infected or destroyed by anything else. Unfortunately, for years they used and probably still do, mercuric compounds, and mercury is a neurotoxin. And then you get into a whole discussion about something called thiomersal and all of the agents that are part of it. And it's one of the reasons we used to use back in the day. When I was a kid, they put it was red. Ask your grandparents about it. It's called merthiolate, tincture of merthiolate. Nowadays, there's a variety of topical antibiotics. We have betadine, you'll all be familiar with, iodine-based compounds, wiping with alcohol and peroxide. That stuff, merthiolate, tincture of merthiolate, these mercuric compounds, bad news. And so the one that's really got some bad publicity due to some poorly done research about 25 years ago that made people sort of created the changes between pro-vax and anti-vax. And the reality is there's a lot more to it that does substantiate people who are not in favor of vaccinations. And there's many, and there's good reason for many cases, not all. So without getting into a long discussion, it's very fascinating. So the secondary response, time's not a factor. They're there forever. So they don't get purged out of your hard drive. They don't get deleted. Don't you like the way I'm bringing in these more modern concepts that you would be familiar with? No response again. 10 o'clock in the effing morning. Wake up. So you have but the chart really shows you. So the immune response initially takes 3 to 6 days to ramp up, and it takes about 10 days to get peak antibody levels. So the next time you get an infection and you go to the doctor, they basically give you an antibiotic that's designed to give you protection for 10 days. Whether it's a Z-Pack, I only take it for 5 days, it doesn't matter. It's based on a time release formula that's released into your system consistently over that 10-day period. Or you get Keflex, known as cephalexin, which is everywhere, and a wonderful antibiotic, and you can probably get 2 or 3 of those a day for 7 to 10 days. Why is that? It wasn't a guess. I think 10 days is about right. It's based on this scientific evidence. The re-exposure, faster, more prolonged because of the immunological memory, hours, not days, peak, couple of days, bind with greater affinity, they're more effective, can remain high for long periods of time. And so here's your primary response in the blue that you can see there. And here the secondary response, bang, immediately. Here's the second exposure, okay? Notice how quickly that ramps up. Now, if you get another exposure to a different antibody, you have to go through the primary again. That's the whole idea. So this gives us the 4 different kinds of immunity classifications. Active humoral immunity occurs when a B cell encounters antigens and produces it. So if it's active, it means you have had an encounter with the antigen. Natural, okay, you actually got the infection, like I was a kid, and we had measles and chicken pox and German measles. So, and I haven't had any more, so I'm guessing it works. Okay, artificial, same deal, except you got an MMR, measles, mumps, and rubella. Okay, and so you're protected for them, theoretically. So of dead or attenuated, dead we don't use so much anymore because we find out that dead doesn't necessarily have the same property. When you hear the word attenuated, think of it as altered. You're trying to make it equally, your immune system equally responsive. So it'll generate the activity, the immunity, etc., without causing you any harm. That's what the attenuation does. It sort of neutralizes its nasty stuff, but I think the right way, retains its original antigenicity and reactivity would be a way to describe it. So they're immunogenic and reactives, and it spares us the symptoms that we were going to get. That's really the basis of all vaccines. Now, they're not entirely the same because we have passive. The idea of passive means since it didn't actively stimulate your immune system, that wasn't you didn't have a primary response or a secondary response. Okay, here you're just getting a certain amount of immunity temporarily. So occurs when ready-made antibodies are introduced. The B cells weren't activated, you don't have the memory, and this degrades over time. 2 types, naturally from mom, okay? So you can see via the fetus through the fetal circulation or through nursing. That's where those antibodies come. It lasts about 6 months. Why 6 months? It takes about 6 months for your own immune system to ramp up enough and recognize what's there and what's not. Versus artificially acquired, and this is injecting somebody with something, some kind of antibody, and the fancy word we use, as you will see soon, are globulins. These are specifically different types of gamma globulins. Those are the ones that facilitate the immunological response. So about 20 years ago, there was a major epidemic that came right from here in a restaurant chain that is no longer with us, and it was in Beaver Falls. The restaurant chain was Chi-Chi's, which is a Mexican in the early days. That was one of the early popular, and it was in financial trouble anyway. And somehow someone there, and it was because of, without giving you a chapter and verse, somebody there effectively contaminated the food because of the way they were doing it, and to some extent it probably came contaminated with hepatitis A. Now, hepatitis A is by no means deadly, but at least more than 1,000 people were infected because first it infects them and it infects people in their orbit, and 4 people died. Not always old and sick. Some young people died. So you can imagine the hue and cry. Interestingly, now there's an immunization for hepatitis A. But there wasn't then. The treatment then was gamma globulin injections. And so that's when the epidemiology people got busy and started looking at it. First time I taught micro was 20 years ago. And this came right during the first time I was teaching it. Very convenient. Thank you. No, I'm not wishing ill on anybody, but it was a great teaching example. So that's what we did with gamma globulin. Another example would be a snake bite antiserum. It's something typically it's called polyvalent. If you're in an area where there's a lot of venomous reptiles, like the Southwest, every emergency room, most doctors' offices have that. An old friend of mine was a lead pharmacist for a big pharmacy chain that service like 6 hospitals in the San Antonio, Houston area. And I mean, I was staying in his house and I opened up, like the bar fridge. There's anti-snake venom. I'm like, what's going on here? You must make an interesting cocktail. Just saying. True. Absolutely true. And there they are. So they're called IGs. I usually just use the term immunoglobulin. And when you look at the gamma globulin fraction in your blood, you have plenty of it. A lot of it you're pre-encoded genetically for, just like with the blood typing and blood grouping. If you have type A blood, like I do, you make antibodies to B. You're pre-programmed to make it. So, and these are capable of binding with antigens detected by B cells. There are 5 categories you need to know. First, before we look at the categories, we will look at the structure. Again, that letter Y or T shape, and it has 4 polypeptide chains. Polypeptides can have up to, I don't even know how many amino acids they have, but proteins by definition have over 100 or more. And so they're usually composed of multiple polypeptide chains, like hemoglobin. Okay, would be a perfect example of that. So they're 2 identical heavy chains, and they join at the middle, creating the quote hinge, and 2 light chains. And it's the tail ends, the tail of the Y or the tail of the T, where the variability comes in, and that's where they're constructed to fit. And it's all about shape, the shape of the antigen. So those antibodies are designed as almost like think of it as a lock and key kind of when they come across a foreign body that's like this, and the antigens like this, and the antibodies like this, and once they form, that triggers a whole series of reactions. So the variable regions at the end of each arm contribute to forming the antigen binding sites, and you'll see that. We call the stems constant. And the beauty of the constant is they determine what class they're in of the 5 classes. And so it's the type of cells or chemicals, how it functions. So, and it does different things. Some of them react with another protein in your bloodstream called complement that accelerates the process of fighting the infection. Some just circulate in the blood. Some go to certain areas where saliva you might have or mucus, it's already in there. Again, and that's all determined by that constant end. Remember those opsonins, they bind to that constant end to facilitate them being engulfed by a macrophage to gobble them up. All that stuff. So it's a well-designed system, and it's a perfectly good schematic. So the heavy chains, the longer ones on the interior, are bound. These are called disulfide bonds. In chemistry, we see, that's why one of the markers we see a lot in proteins are sulfur, where we see very little of it in DNA and RNA. We see a lot in proteins because it's particularly how proteins latch on to each other. So it's like 2 groups with sulfurs next to each other. They're called disulfide bonds, and they're really significant that are there. So you can see, and it's these regions where we see the variation. And again, there's a lot to it. That was schematic. There's a lot more substance to it than you and I might think. These are the classes. This is the very acronym I use to remember it. MADGE. Anybody named Madge? Older people who were named Margaret either went by Peggy or Madge. Okay. Names are different. My daughter, like a lot of girls of her age, were named for somebody in a TV show back in the mid-'80s that Michael J. Fox was on. Her name is Mallory. His sister's name is Mallory. Justine Bateman played the sister. So there were a lot of Mallories. It has to do a lot with, who's around. So the IgM is the largest rather, and it's the first one that enters your bloodstream. Why is that important? So when we do blood tests and you're checking to see whether you're early in the infection or late in the infection, what you'll do is you'll do antibody testing to see which one is there. And if there's an abundance of IgM, you know you're in the early stages. If there's an abundance of IgG, you're in the later stages. So it's a way to so it's almost a way to channel the. It's an involved test in the laboratory, however. It's a pentamer, which means there's 5 of those Ys latched together. You'll see the illustration. And what they do really well is latch onto multiple players. So agglutinating is what happens when multiple antigens are latched onto at the same time and form large clumps. Large clumps are easy to be swallowed up because there's so many of them. So secretory, or IgA, is typically starts as a single and becomes, you'll see the illustration, a dimer. This is the one that's protective. You have it in mucus, you have it in saliva, you have it in anogenital areas. It's there all the time. It's a major defense. That's part of it. So it's really important. And so it's more about getting in the first place. So they're part of that natural immunity that we had talked about previously. It's a very artful job you did on your reference sheets here. Just look at your, it's okay. No color?
Since you colored the library.
There are places where you can print these things.
Where?
Is there a FedEx Kinko's anywhere around here? There's got to be one over in Robinson. I wonder if the print shop could do that. So, I mean, I know a lot of students have their own, they bring their own printers with them. Okay. I always print in black and white here. I print in color for you at home. Hey, that's when in doubt. It'll work. So this is what it looks like. So here's the pentamer, particularly useful. And like I said, the first one, so that's 5 individual ones. Here's the dimer. So in limited amounts in the plasma, mostly in other areas, saliva, sweat, intestinal juices, milk in the sense of lactation. Okay. Nobody really knows what IgD is. Okay. We know it probably plays a role as a B cell receptor. It's on the B. When you saw the B cells with those things sticking out, they're probably IgD. I say that because most of the time books that you read and the articles you read suggest that it's likely IgD does this, which is short for we don't know. The one that there's by far and away the most of, the ones that is produced in vast amounts with an infection, is IgG. 75% to 85%, so 3/4 to 5/6. Secondary and late primary responses. This is the one when the mom gives protection to the baby. This is the one because it has the ability to cross the placental barrier. The placental barrier is an interesting barrier. Not everything can do that. Okay, that's why we worry so much about a virus like German measles, which is a particularly, and that's the R for rubella. I had this about 3 days. Okay, it's a mild rash. You don't even know if you're sick. Maybe you maybe have 101 fever. If you did, you could go to school if you felt like it. That kind of thing. But the problem is just that people either don't know they're sick or not, or they choose to go to work and they're not, and they run into somebody who's in their first trimester, and there can be a lot of problems associated with it. I get into that in my group. And IgE is something we see a lot, particularly in allergies and parasitic reactions. The word parasite in this context has to do not only with, it's a fine line. Bacteria and viruses effectively are parasites. But when they say parasitic infection in this context, they're talking about infections with eukaryotic cells, like, and you learned about what eukarya are. Bacteria and viruses are not. They are not the same as our cells. These are fungi are the same as our cells. Worms, similar to our cells. A lot of the agents that provide water contamination, like Giardia and amoeba, are not like our cells. That you would see elevations of those factors that are there. And again, these are all monomers, and you can read through that. So interestingly, they can switch It's like they'll start with IgM and they'll go to IgG. Okay, so IgM is released early, IgG later. So you can see they can switch around, which is certainly advantage. This is what they do. What antibodies do more than anything else is they are able to create. The boss wants me. Okay. What is she texting me that for? Don't know. She's shopping. She's for the business. So that was a half an hour ago, so I didn't get her. I shut off the ringer. I'm sorry. If your significant other texts you, you get back to them, right? Right? See? I have regard for my own health. There's health and safety issues. Okay, so here's how it works. So they tag, but they don't tag the same way. A toxin, common problem. People get a bacterial infection. Most of the bacteria do their dirty work by making toxins that damage cells, that damage linings, that create problems, damage tissue. Neutralization is just that, neutralizing the toxin. It's what happens when you get a tetanus shot. That's what they're attacking. You're actually getting 3 immunizations at once for whooping cough called pertussis, tetanus, and an old disease that I've never seen but heard a lot about called diphtheria. So it's DPT or DTaP, diphtheria, tetanus, and acellular pertussis. And those are all mediated by toxins. So they neutralize the toxin. When they neutralize it, then it becomes something that the white blood cells can attack. The agglutination, making big clumps. A lot of things are soluble. When they're dissolved in the bloodstream and the plasma, white blood cells can't find them. When you precipitate them out, that's a big deal. So now the white blood cells can find them. It slows them down and makes them visible. And lastly, again, complement is an agent that your immune system produces. And what it does is it makes it work more efficiently. So that constant end on the antibody is able to attach in such a way that it makes it doing its job more easy. Neutralization, specific sites on viruses or bacterial toxins. Viruses don't really have toxins. Viruses damage cells directly. So, I mean, but that's what, so it prevents them from damaging the cells by attaching and entering the cell or attaching to the cell. Doesn't let them bind on certain cells, facilitates phagocytosis. So each antibody has 2 arms and they combine and it forms like a big clump. It's called agglutination. The perfect example is when if you ever did the little drop test and saw speckles with blood types, you would see that. And we saw an illustration of that, I believe. And then the precipitation, again, complexes are easier to identify. There's a certain good news and bad news about complexes. Okay? And the same with agglutination. The biggest problem with mismatched blood cells, and I told you this, is you get clumps in the kidney. Certain diseases, most notably strep throat infections or other streptococcal infections that aren't treated properly, they can form clumps that damage other things. And again, we go over that at length in micro when we do skin and respiratory diseases. So one of the things they certainly do is the kidney is one of the targets because kidneys are finicky. If they're damaged, and particularly if they get clumps of proteins in them, they stop working. Big problem. Here's the complement fixation against a variety of things. Complement binding sites align, as you can see. They amplify the inflammatory response. They lead the way to this opsonization so they can be swallowed. And they show you all these that are there. When we have, and I don't know enough about worms. If you want to learn about worms, and I say this is micro, best person, if you have a vet that you go to or a family vet, go talk to them. Because, animals out, particularly outside animals, are constantly into stuff they shouldn't. Like I'm fond of saying my dog explores the world through his mouth. When he was a puppy, I was just all chewed up. So worms are too big, okay? So that the strategy is kind of interesting. They have an acronym, it's not important, but the IgE binds to the worm's surface, and then eosinophils come along and bind to the IgE, and the eosinophils release chemicals to start to, because worms are just long chains. They start as like single cells microscopically, and most of them are just long chains, like a tapeworm or heartworm. Yeah, and most people are a little more familiar with that if they have a pet, particularly around here. They should be on some type of heartworm prophylaxis. And these are important too. Monoclonal, they have been around a long time. So I was hearing about them 50 years ago when I first started to learn about antibodies. Pure antibodies that are specific for a single antigenic determinant. And these are special cells that actually they use a tumor cell with a B cell to make them. And I heard about them in the use of treating cancers. If you knew somebody during COVID who had one of the treatments was monoclonal antibodies. They had a variety of areas where if you tested positive, there was a government program, even if you did not have insurance, where you could get effectively a $2,000 monoclonal antibody infusion. They put you on an IV for an hour. And I know because my kid had it done. Okay. So he didn't have, where he was working, didn't have health insurance at the time or hadn't worked there long enough. And it was about $2,000, but because he tested positive, when they tried to charge him, since he didn't have a positive test, they didn't insure it, so he didn't have, the government took over that $2,000. Thankfully. And it was, he said it was awful for about 24 to 48 hours. Then it worked really well. I forget, I'm trying to remember what the name, but it was a combination of two. And so this is just a summary. They don't destroy it. They just prepare it for destruction. Antibodies can act inside if attached to a virus before it enters the cell and destroy the virus. That's interesting. I don't think it's that terribly relevant for us. And so that concludes the second of the 3 PowerPoints. And frankly, the last of these 3 PowerPoints, I think, is the most complex with cellular response. And I'm just going to introduce it today. And maybe do 15 or 20 minutes on it. So there's a lot of it. I'm sure as you're listening to this, and it's difficult because like you're looking at your diagrams and stuff like that. It's not my first rodeo. Born at night, not last night. 3:05 in the morning. That's with my sister. She was born 2:05. 5 days, 5 years, 7 months, 1 day, and 1 hour difference. She came up with it, not me. She's normal. I'm not. Okay, this is very famous. T cells, forever known as killer T cells, also known as cytotoxic, which means killer T cells, deadly to cells. This is if it's a cell that's been infected with a virus or a bacteria, cancerous, abnormal, transplanted, transfused, that is, your body views this as a foreign cell. Okay. Some directly kill the cell, some release other chemicals that play a role in the immune response. They are extraordinarily important. The single most important cell in your whole immune system is known as a helper T cell. It's the cell that makes tons of chemicals that support the innate system, the humoral, the B cell system, its own system. I told you before, but I'll just say it again. That's the cell that's directly affected and invaded by HIV that destroys that line. And once that falls below a critical level of healthy helper T cells, you make the transition from HIV positive, which is treatable and survivable, to AIDS, which is by definition fatal. There's a difference between them. You know, effectively, we're all going to die at some point. If you die before your time because of a disease entity, that's what makes it fatal, or a fatal condition like a cancer. They are much more complex. They are based on two population T cells are based on which cell differentiation glycoprotein receptors are displayed. Without going crazy about it, it's very simple. If it's something called a CD, this is the part you need to know. If it's CD4, it'll become a helper T cell. Okay, and helper T cells are just that. They help the other cells. Some of them are called regulatory T cells. They play a role. In the old days, we used to call them suppressor T cells. Your immune system is very vigorous. So you need something to activate it, the helper T cell. And in the old days, you needed something to slow it down before it got out of hand. That's cool. Now it used to be called a suppressor T cell. And in the early days of HIV and AIDS, we checked the ratio, the relationship between helper and suppressor cells. And I changed the name. Now they call them regulatory because it does more than just slow down or stop the immune response. It tends to keep it in check. Be the best way to describe it. So, but the idea is the helper T cells, the single most important, regulatory T cells, and just like the antibody system, immune cells. So we can have memory T cells as well. So and not everything works as effectively, okay, in this, let's say, as there's probably less immunizations that work effectively. For instance, we do not use it in this country. There is an immunization for tuberculosis, okay, and that is used in other countries, particularly India, where it is rampant. Okay, it is much more effective in children than it is in adults. However, if you wish to travel to India, you need to have that immunization in order to get, so your visa will be approved for whatever reason. The bad news is that because of that, it will always, when you have to get a test at work, when they want to do a tuberculin test, if you're going to work in a hospital, they're going to do that, you always are going to test positive. That's why we don't use it in this country, because it renders that particular screening test useless. But they have much more problems with TB there. That's why I'm here. Why do I know that? Did I tell you about my daughter more than once? My daughter, well, I would say minimum 5 times in the last, none recently, between the time she was 20 and 30, was an egg donor. And most of those procedures were done in India. Because for wealthy couples, because it would cost a couple $100,000. And they would, and they would pay whoever the donor was. And they would have all her expenses, and she'd be able to travel with somebody. And we've had students here who, for whatever reason, because it's a lot of it's about looks, is have had solicitations from some of these companies. And because when she did this in India, that was one of the they gave them. You get a lot of chemicals. I tried to get her to stop. I mean, but, what she wants to do, not even longer. CD8 cells become cytotoxic. That's the one you have to know. That's there. So helper, cytotoxic, known as killer T cells, CD4, CD8, regulatory, which are in the helper, sort of relatives of CD4 cells, and so-called activated T cells. And confusingly, they use the term naive. So a lot of times naive is used for a T cell that hasn't been activated. It means it's able to be activated, but it's not. But the reality is that most time we just call them CD4s and CD8s. And they show you the 2 cell lines that are there. And so there's a lot that goes on with this. So it starts with this lymphocyte. That's the originator. These mature in the thymus, and they're either going to be CD4s or CD8s. And that's based on, the structure of that receptor. So the CD4 with an antigen presenting cell, remember this is the invader, here and here, it'll be activated. And again, once it clones, the CD4 mostly effector cells, either helper or regulatory cells, obviously some memory cells. And the same here, mostly these so-called killer or cytotoxic T cells. Okay. So you have, it'll say like T cells sub C and T cells sub H. You see a little H and a little T next to it, is what it becomes. T cells respond to tiny fragments. So that's what the antigen presenting cell does. It latches onto it and it presents like a fingertip, if you will, of that invader. And then it goes from there. And so that's the critical piece. It has to have one of these antigen presenting cells. And interestingly enough, this is the part that's confusing. So however you want to memorize it, memorize it. I think it's important just to know it because I'm worried about licensure exams and test questions that they might ask. MHC stands for Major Histocompatibility Complex. That's basically what identifies as self and non-self. So we have things called class 1s and class 2s. Okay. And so the class 1s, okay, without going through all the jazz that's there, class 1 CD8, class 2 CD4. That's it. Class 1s are for basically for cells that have been invaded more than anything else. Class 2s are a little, so class 1s inform the killer T cells of microorganisms hiding inside, virus or bacteria. Abnormal proteins found in the cell. That's what it means. Class 2, fragment sizes are different, okay, and basically they're just a signal for help. And the helper T cell, once it's activated, works in concert with this killer T cell, works in concert with the innate immune system, works in concert with the B cells, all of those things. That's why it's so important. And again, like anything in your body, there's a good news, bad news. When it's overreactive, an immune system that's out of control is awful. So I just told you about that shot from India. It's got a fancy name. It's called BCG. It's got from 3 French doctors and they're called Biol, Calumet, and Guerin. So they call it BCG. We use it a lot today for immunotherapy. Rather than treating, understand what cancer is. For years, the way we treated cancer is we cut it out and we bombarded people with nasty chemicals called cancer chemotherapy. Lost their hair, couldn't eat. Sometimes they died from the treatment. Or bombarded them with radiation. Same deal. Okay. It's not scientific, but in some cases it worked. In a lot of cases it worked, to be fair. What they have discovered last 30, 40 years is a lot of cancers respond to immunotherapy. Interestingly, they used the mechanism of tuberculosis, which is a bacteria that goes inside cells. So what they did was they gave people, depending on circumstances, this BCG. And what that did is it went inside the cells and triggered the cells to respond. And that basically caused your immune system to ramp up to fight, in particular, cancer. I had this done when I had bladder cancer. So the treatment, I probably had a dozen treatments with this. So the good news, they're very effective. The bad news, they're very hard to tolerate. And each time my reaction got worse. And what it did was it likely triggered a pre-existing rheumatological disease, a kind of, and we'll talk about that in this unit, a kind of inflammatory arthritis. It's very similar to psoriatic arthritis. So in ramping up the immune system, you run the risk of triggering immunological problems with an overactive immune system. The backside is the same thing. If you try to suppress the immune system when somebody has an immunological disease, and that's how most of these things work, the trouble is they're much more predisposed to cancer. It's this. And that's medicine 101. Okay. The scales of justice thing, all that. It's a very fine balance. So I've been through it on both ends of it. So I do no longer get those treatments, and now I have to take every 2 weeks, which we'll talk about, an immunosuppressant. So this is sort of the interesting nugget here at the end. Class 1s and Class 2s, all the stuff that's part of it. Class 1s, CD8, changes in Class 2s. Affects all of these. It affects the dendritic cells, macrophages, and B cells, so it's got a wider range. And again, they're different. And there's different kinds of restrictions, and we're not going to go there with all that. There's a complex process that's involved with it that involves first the antigen binding and then what's called co-stimulation. And I'll show you the video, but I'm not going to go through all this stuff that's there. I just think it's, and this is the whole idea down the road. T cells they're so aggressive that fortunately they're programmed to die. Apoptosis is programmed cell death between a week to a month. If they did not, then you would be overwhelmed. So they're a hazard. Like me, they could result in hyperplasia, growth of tissue, or cancer if not cleared. So, I mean, there's a lot that goes on. There's this whole process of slides. And the chemicals that are involved, this is the name I've told you about before, they're called cytokines. Cytokines influence other cells to move. They're chemical messengers. So whether they make the cells develop or change or respond, different. So the names, and I told you about one before, is in our innate system is called interferons. They're for viruses. Interleukins, okay, a name, and classically we call them ILs now. Basically, there are different ones, and they all have different roles. So generically, just know the term interleukins. The one that surely is the most important is this one, IL-2. For years, when we started to harvest it, that was a cancer treatment. They would try courses of interleukin-2, and still do to some extent, because it's a key growth factor, encourages T cells to divide, amplifies their response, okay? Killing power of macrophages. And there's, as you can see, and there's more than these, I'm sure. For instance, okay, just to give you some context with this, initially, this is called interleukin-17. Don't have to know this from my advanced class. Secreted by helper T cells and involved in inflammation in many autoimmune diseases. So what it does, it's a pro-inflammatory. So initially, I took an injection called Cosentyx, which you see advertised on TV. It fights this. That was what they were, after I got this immunological flare. It's also hard to tolerate. I mean, you're just like, I'd have to take it Friday night so I'd be able to come back to school on a Monday. Just kind of out of it on Saturday. Just doing a lot of stuff inside. Now they changed that, and now this is the ones called tumor necrosis factors. Produced in large amounts, promotes inflammation, enhances, slows tumor growth. So effectively, that's the one, and what it does, I take something that causes this to slow down. Okay. You'll see it advertised all the time. That's the Humira. A previous one that's still utilized is called Enbrel. My wife at the time, back in started this in 02, 03. It's interesting, even though we have no other relationship other than being married previously, and it's not transmitted to one another, both had variants of psoriatic arthritis. So she had that and was being treated for that. It was really, my boys, when we were like just driving, 17, 19, we'd have to sometimes carry her home from work. She was in 6th grade. They gave her the Enbrel, and it really helped. Injection every 2 weeks. Like, give her an injection in her thigh or in her arm, wherever it was. And she developed, because she had an interesting disease hereditarily called neurofibromatosis. That, in its worst, not its worst, but one of its worst presents is the elephant man disease, which means that she grows nerve and fibrous tumors in a lot of area. She developed one in her abdomen. We thought it was something terrible. And because she was taking that she had to have a major surgery in 2004. We have wonderful medical examples in our family. My previous family and my current family, and the combination of both. So interestingly, I'm taking that. It's been very effective. Okay, and so the helper T cell plays a role in all the arms. Once it's good to go, it activates B cells, it activates T cells, it causes them to proliferate and secrete cytokines. Without it, it doesn't work. That's why it's the single most important cell. And they go through all the ways it's activated. And I'm not going to do any of those with all of you. And it's somewhat complex. So let's stop it there. There's an animation that's pretty good in this that I hopefully did not, this one, that we'll look at next time, but it takes a little time to go through. Okay? So thank you very much. Get done a little early. There's a lot of material to present today.